Good morning, good morning, good morning, good students. It's JD here. Today we are going to quickly proceed from where we left yesterday. Remember, we are busy revising the question paper that was written last year, that is in October, November 2023. This is O-level mathematics, and currently we are revising paper 1. Yesterday, we looked at question number 22, whereby we explore a lot of questions as far as functions are concerned. As we see here, f of x was given, g of x was given. In the first question, we calculated f of minus 8, and we got the result here as 1. We've also looked at part B, whereby we looked at the inverse of a function. Remember what I've said as far as the inverse is concerned, that for you to find the inverse of a function, replace f of x with y, and then on the next step, swap the variables, let x be y and y be x, and then after that, we then manage to make x the subject of formula. We've also looked at this question whereby they say find the value of p if f of p is equivalent to g of p plus 5. So we started by calculating f of p, and we've also managed to calculate g of p plus 5, and then after that, we managed to equate the two results and solve for p, whereby p came as minus 20 over 7. So for today, let us quickly extend our understanding looking at question number 23. Wow, question number 23 is for vectors. Vectors, 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 vectors. This is a very, very, very interesting question. The diagram here is written that it's not drawn for scale, but let's quickly see what exactly this diagram that we have at hand. So in the diagram, OABC is a parallelogram. What is a parallelogram? Remember, you need to understand the properties of a parallelogram as you are doing this vector geometry. So we know that the length of line OB is basically equivalent, not the line OB, sorry, the line AB is basically equivalent to the length of line OC. And also remember, line AB and line OC are also parallel. So if these lines are parallel and also they are of the same length, it means the vector AB by the end of the day is also equal to vector OC. Why? Because we know that as long as vectors are in the same direction and are of the same size, therefore they are equal. So vectors are said to be equal if they are of the same size and are in the same direction. So in this case, vector AB is equal to vector OC. Okay, what about the vector OA? The vector OA is also equivalent to vector CB. As you see, OA is parallel to CB, and also OA is of the same magnitude with CB. So yes, these vectors are equal. So as long as if you know that vector OA is A, so also vector CB is also vector A. If vector OC is C, the vector AB is also C. Quite interesting. Let's quickly move on to the next slide. Let's say X is the midpoint of AC. So as you see, this is our line AC, this is our line AC. So they say X is just along this line and it is on the midpoint. So what does that mean? So if X is the midpoint, so vector AX from A to X is basically half from A to C. So AX is the half of AC. And what about vector C, XC? Vector XC is also equivalent to half of vector AC. So once we know vector XAC, it will be very easy for us to deduce vector AX as well as vector XC. Let's quickly move on to the next slide. On the next slide, they say Y is the point on AB. So we also have point Y here. So Y, they say this point on AB is on this line AB. In other words, AYD lies on the same line. So Y is the point on line AB where AY is to YB is 2S to 1. So from AY is converted from YB is 2S to 1. So the distance from A to Y is almost 2 times as that from Y to B. So if you have to interpret this ratio, vector AY, so from A to Y, it's basically 2/3 because we've got 2 parts for AY and 1 part for YB. So total part is 3. So AY is 2/3 of AB. And also YB, vector YB is 1/3 of line AB. This interpretation is very, very important. You know, as long as if we know vector AB, it's easy for us to find vector AY. As long as if we know vector AB again, it's also easy for us to find vector YB, taking advantage of this ratio. Let's quickly move on to part A. Part A is written. Express as simply as possible in terms of vector A and vector C, the value of vector AC. So what is the vector AC? So what do we mean? Let's say we are at position A here, right? This here, we want to go to point C. So how are we going to move from A to C? So let's identify the path that we have to follow. It's very important. So identify the path from A to C. We can move from A to O, right? Once we've arrived from O, then we'll edge from O again to C. So for you to move from A to C, you can take this route from A to O and then from O to C. So vector AC is the same as vector AO plus vector OC. So now let us substitute. Here it's given that vector OA is given that it's vector A. What about the vector AO? Right? So remember OA, distance-wise, OA is equivalent to AO. Right? Distance-wise, it is the same. But vector-wise, vector OA is the opposite of vector AO. So obviously, this will be negative A. So you may find that if vector OA is A, then vector AO is negative A. So here we want vector AO. So it's going to be minus A plus, what is the vector OC? Given straight away that it's Z, it's vector C. So if you want to rewrite our answer, remember addition is cumulative. So you can also write this as vector C minus vector A. So yes, this is our final answer. Let's quickly move on to part B. We are looking at we want to look at the position vector of X. So in other words, we want vector OX from the origin, the position vector of X. So what is the position vector of X? So as you see here on the diagram, we want to move from O all the way to X. So that is from point O all the way to X. So let's identify the journey. So for us to move from O to X, the best way we can do, let's take a route from O to A, and then from A, we go to X. Let's quickly do that. So what is vector OX? The vector OX is basically equivalent to vector OA, right, plus vector AX. Right, as you see here, you can see clearly that if you want to move from O to X, you can take this route from O to A and then from A to X, right? And the vector OA is given, and vector AX, we want interpreted vector AX at this point, where it was given that X is the midpoint of AC. And we interpreted and say, if X is the midpoint of AC, therefore, vector AX is the half of vector AC. And vector XC is also half of vector vector x is also half of vector AC. So here we can simply plug in information that we have. What is vector OA? So vector OA is basically vector A plus what is vector AX? Remember, we interpreted vector AX previously, whereby we said the vector AX is basically half of vector AC. So AX is half of vector AC. So on the next part, what is vector A? Let's write vector A plus half of what is vector AC. We have calculated the vector AC in the previous question. So we can simply substitute vector C minus A. Let's quickly simplify this result. So if we simplify this, we can keep A, and here it's 1 over 2 times C minus A. So it was a term that is multiplying an expression. So we're going to multiply all the terms inside the brackets by that term outside the bracket. So 1 over 2 times vector C, we're going to say half vector C. 1 over 2 times vector A, we're going to get minus half vector A. So if we simplify this further, you can see that A minus half of vector A, we get half of vector A, and also plus vector C. So remember what I did here, I simply collected the like terms, vector A minus half of vector A plus half of vector C. So A minus half A, we got half A, and plus vector AC. So yes, this is the solution. Let's quickly move on to part C. Just imagine, this is paper 1, but I want you to take a closer look at the marks that we have on this question number 23. On question number 23 for vectors, we put 1, 2, 3, 4, 5 marks. Oh my God, wow. 5 marks for vectors. So guys, we need to master this chapter since it is likely going to be examined in your exam. Okay, let's look at the vector yx. Let's go back to the diagram. We want the vector yx. We want the vector yx. So which vector is it? So we want to move from y all the way to x. Right? So how are we going to achieve this? So as you take a closer look, what will be their path? We can move from y to a, and then from a to x. There are other options. You can even move from y to b, and then from b to c, and then from c to x. Or you can move from y to b, and then from b to c, and then from c to o, and then from o to x, or from o to a, and then to x. But those routes seem to be a bit complicated. It's easy for us to take route ya and then ax. So vector yx in this case is going to be the same as, let's see the path. So vector yx is going to give us, ya, vector ya plus vector ax. The interesting part is vector ax, we've already calculated in the previous question. So we need to focus on calculating vector ay. But remember, I interpreted the vector ya before. Right? But I interpreted in form of vector ay. So what is vector ay? Let's take a closer look at vector ay. So vector ay, we said it is basically equal to 2 over 3 of vector ab. Right? So this is equivalent to 2 over 3. And what is vector ab? Remember, we said the vector ab is the same as a vector OC. So vector ab is also vector c. So vector ay is 2/3 of vector c. Therefore, so if vector ay is this, then what does that mean? It means the vector ya now is negative of this vector. It's negative 2 over 3 of vector c. Okay, so now we have the information. We can go back here to our question in plug. What is vector ya? It's negative 2 over 3 vector c, plus what is vector ax? Remember, we have already calculated vector x, and we said vector ax We did vector AX here. Remember, we said vector AX, we recently said it's half of vector AC. And this was equal to half of, remember, vector AC, we said it's basically C minus A from the first question. And when we have simplified this, we got half of vector C minus a half of vector A, as we did here. So we can take the value of vector AX. What is the value of vector AX? It's the half of vector C minus the half of vector A. So what is the next move? Next move, we have to simplify this problem. Let's simplify. Let's simplify by simplifying like terms. So what is minus 2 over 3 plus 1 over 2? So this is just the same as 1 over 2 vector C minus 2 over 3 vector C minus 1 over 2 vector A. So we need to know how to subtract fraction. What is 1 over 2 vector C minus 2 over 3 vector C? So here the common denominator is basically 6. And you pay 2 into 6, you get 3. 3 times 1, you get 3 vector C. 3 into 6, 2 times this one, you get minus 4 vector C. All right? Minus 1 over 2 vector A. So if you simplify this, you're going to get minus 1 of vector C all over 6 minus 1 over 2 vector A. So yes, this is our final solution. So this is all you need to know when it comes to vectors. So vector geometry, when they say it's a parallelogram, it was good for you to interpret, to understand the properties of a parallelogram. We need to know that vectors are equal if they are of the same size and are in the same direction. So we applied that concept, and also need to understand ratios. Remember, ratios are also used in vector geometry. So understand when they say this point is the midpoint, what do they mean? When they say this point is to this point, probably in this case, was said 2:1. Interpret that ratio. There are a lot of marks at this part, and I've seen a lot of students losing a lot of marks in vectors, yet it's very, very simple to tackle them. What is very important, especially when you're dealing with vector geometry, first thing, identify the path from a certain point to a certain point. As you see what we did on the first question here, and what we did on the second question here, and what also we did on the last question. So yes, that's all about vectors. The first question, 1 mark, 2 marks, and lastly, 2 marks again. So yes, this was a very, very, very interesting question. Let us quickly move on to another question, which is question number 24. Okay, this question is very